Hello and welcome back to another video. Today we're taking a look at an electrostatic question. It says a charge of -4 nanocoulombs is located at 0 and 1 meters. They're saying what is the x component of the electrical field at a given coordinate of 4 and -2 meters. Okay, so the way you do this question is first I would like to kind of put up a coordinate system for us. Let's put it up. So this is the y, and this would be the x-axis. The -4 nanocoulomb charge is located at 1 meters. So let's say this is 1 on the y-axis, and this is 2, and then let's say this is -1, and this is -2, and here we have 1, 2, 3, and 4 on the x-axis. So the -4 nanocoulomb charge is located right here at the 0 and 1 mark, right? Because that's the positioning that is given to us. This is 0 and 1. And this is where the -4 microcoulomb charge is. They are saying, what is the x component of the electrical field at a coordinate position of 4 and -2? So x is 4, y is -2. Now, that would mean that we'd have to come here and here. So that would be where we want to find the net electrical field. Or actually, sorry, the x component of the electrical field. So we would have to find E of x. So, well, what do? The first thing you have to understand is this is a negative charge. So you would have this sort of a line coming inwards into that position. That would be the component or the vector of this electrical field. And as you can see, it's going at an angle of theta. And it actually kind of forms a triangle if we were to kind of see the situation down here. The triangle actually would have a length or a base of how much would that be? Well, it goes from here would be 0, so 0 to 4. That would be 4 meters down here. And then if you were to count the height of the triangle, let's say this yellow line would be the height. It would be 1 to 0, and then from 0 to -1, and from -1 to -2, that would be obviously 3 points, right? So 3 units. So the length of this side, let's say, is 3 meters. And obviously, this is a famous triangle because we know the triangle or the golden triangle rule, whenever you have 3 and 4 on one of the legs of this triangles, then you can say that the hypotenuse is 5. You can go ahead and try the Pythagorean theorem to find out that it's 5, but I can just say that it's going to be 5 right off the bat. So the distance of the electrical field from that point, which we can call point x, e, whatever, to the charge, which is -4 microcoulombs, is 5 meters. So we can actually calculate the amount of the electrical field at that point, which is kq over r squared. So we can just say 9 times 10 to the power of 9 times 4 times 10 to the power of -9, because it's nanocoulombs, divided by the distance, which happens to be 5 squared because it's 5 meters, but we have to use a square on there. Now, if you put that in the calculator, you should get 1.44 newtons per coulomb. That's going to be the electrical field at that point, but it's not the x component of it, right? Because now you have to break down that vector into its x and y components to find out its x components. The vector is going this way. This is E, which is 1.44. However, the x component of it will be going in this direction. We can call that E of x. And the y component of it, which I'm going to use another color to draw, is going to go up. So that's going to be EY. Now, here's the deal. The angle here, theta, is not stated by the question. So for us to be able to find that theta, we have to use any trigonometric ratio from SOHCAHTOA or sinus, cosinus, or tangent. I'm going to use sinus there. So sinus of theta there is going to be the opposite side, which is 3, over the adjacent, which is, sorry, over the hypotenuse, which is 5. So theta here will be the sinus inverse of 3 over 5. So what I did is I didn't know what that angle is, and I need it for the components. Thus, I need to go ahead and find what theta is. So theta is going to be, if I take sinus inverse of 3 over 5, it gives me almost 37 degrees. So theta is 37 degrees, all right? That's pretty cool. Now that I know that, I can go ahead and calculate E of x. E of x is sitting beneath that angle. It's adjacent to it, so we can find it by saying E times cosinus of theta. So the x component of this electrical field over there is going to be E, which is 1.44, times by cosinus of 37. And 1.44 times cosinus of 37 is 1.15 newtons per coulomb. However, keep in mind, because it's going inwards as the charge is negative, the answer is going to be negative 1.15 newtons per coulomb, which will make choice D the correct answer right there. that's going to be it. Thank you for watching. Take care and best of luck.